Good day, everyone. Hey, this is actually going to be our last instruction video for the year. Believe it or not, today's Monday, May the 11th, and then my plan for this week, guys, is Wednesday you'll do a little review of the last three lessons on Introduction to Circles, and then Friday you'll have your last quiz of the year in Math Excel over those first three lessons about circles. Okay, so this is the last this is the last lesson for the year and your last regular homework assignment today in Math Excel. Okay, so today you're going to be introduced to another way of drawing an angle in a circle. That's going to be called an inscribed angle, and you're going to be studying how it's related to the arc that it intersects on the circle. So let's actually first review another type of angle measurement, and that was a central angle. And this was a topic in a previous lesson. A central angle was the one where you have 2 points on a circle perimeter, like R and T, and if you connect them both to the center, you now have an angle at the center, and in this one it would be angle RST, or you could just call it angle S. And of course we could measure it, and its measurement is the same in degrees as the measure of this arc. And so in this one, you're told that this arc is 50 degrees. And that means that the measure of this angle S is also 50 degrees. So an easy relationship for central angles is that the measure of the angle in the center is the same as whatever the measure of the intersected arc is. So angle S is intersecting the arc RT, and they both are measured 50 degrees. So the next topic would be, or the next way we're going to actually draw angles, and we'll introduce this on the next slide a little better, but let's say we took that same 2 points, R and T, but let's say instead I were to take a couple of other straight lines and join it to a point that's on the other side of the circle somewhere. I'm going to try and grab my line tool. And so what I mean by that is, let's say I was going to connect R to like point Q, let's say, for example, and then connect T also to Q. And now we've got this other angle, let's just call it angle 2. Okay, angle 2. And so the main topic of today's lesson is, how does the measure of angle 2 compared to the measure in the center angle when both angles intersect the same arc, RT? Just by quick glance, it doesn't appear like they're the same. Angle 2 definitely appears like it's smaller. You might want to take a guess as to how it is related before we move to the next page, next couple of pages. So let's actually make a definition now. And what an inscribed angle is an angle we get when I take 2 points on a circle, like in this picture A and B, and then I draw a straight edge or a segment from both those points to a single point across the circle somewhere else, and the vertex of that angle is now on the perimeter of the circle also, not in the center, but on the perimeter. And so angle C is an inscribed angle, and it intersects the arc AB. Okay. The first question in your assignment today is just about this, like what arc does the angle intersect? So you can always tell that just by starting at the vertex, opening it till you get to the other 2 points that are on the circle, and that arc between those 2 points is the name of the arc. So that's the important information that I'm circling right here, that the angle C is the inscribed angle, and the intercepted arc is arc AB. So the next topic is, how does the degree measure of this angle, this inscribed angle, relate to the angle measure or the degree measure of this arc? Okay. And so here's our rule. Remember, in the first time I drew this a couple of slides ago, it looked like the inscribed angle was definitely smaller than the central angle, where both angles had the same intersected arc, and that's exactly true. In fact, it's not just smaller, it's going to be, it turns out that it's exactly half. Okay, so the rule for today here is that when I draw an inscribed angle, the measure of the angle will always be half of the intersected arc. So let's say that on the perimeter of the circle, this was a 80-degree arc. The rule says then that angle B is going to be half of that, or 40, which is half of 80. You can also use the rule in reverse, right? So instead, I could say it like this. If I multiplied the angle by 2, we get the measure of the arc, in this case AC. Right? So in other words, if I had given you the angle 40, you can use the relationship this way and just say, okay, I'm going to double the 40 and know that the angle is going to be 80. Okay, so it works both ways. So if you're given the arc and you want to find the angle, you got to cut the arc in half. And if I'm given the angle and want to find the arc, I got to double it. Okay, so that's how it's going to work. Okay, so in this picture in problem 1, you have to find the measure of one arc and you have to find the measure of one angle. So it says find the values of A and B. Well, A is the number of degrees of the arc PT. Now for this diagram, I'm going to use my highlighter pen to highlight things like the arc that's in question in the first part, which is A. The part goes from P to T. Now, what I'd like to also highlight then is the inscribed angle that corresponds to that arc, and I'm going to trace it with the blue pen here now. It's angle Q, and it goes from P to Q and then from Q to T. So but the angle vertex is Q and it's on the circle perimeter, which makes it an inscribed angle. And so the key notice is that the measure of the angle was 60 degrees. The angle PQT is 60, and then it opens up to the arc of the circle, which is from P to T. So if you think back to the last page, remember I said if you start with an inscribed angle and you want to measure the arc, you have to double it. And so all I'm going to do is take 60 degrees times 2 and get 120 degrees. That makes this one 120 from P to T. Okay, so there's that. Now for B is an angle measurement. It's the angle R, or I should probably call it angle PRS. Okay, so I'd like to actually erase the highlights now, so I can go back and re-highlight the relevant information in this picture. So I'm going to actually grab the yellow again, because now angle B, or the angle PRS, opens to P and extends all the way to S. So I have to extend this yellow highlight all the way to there now, and I'll use the blue again to highlight the inscribed angle. Okay, so this time we want to know the angle and I need to know the arc that's in yellow. If you'd like, I'd like you to pause the video for a minute and see if you can determine how many degrees is it on the arc that goes all the way from P to S. And hopefully you did that and noticed that since we found in the first part that from P to T the arc was 120, and it was given that from T to S was 30 degrees, I now know the arc PTS. Okay, so let's make a note of that. The measure of arc PTS is 120 plus 30, in other words, 150 degrees to go all the way around from P to S this way. Now the inscribed angle associated with that arc is the one with B on it that we want to know, and it is right here. So we want to use that relationship in reverse. I know the arc is 150 and I want to find the angle, so we're going to take half this time. So instead of doubling, we're going to take half. So B is going to be 1/2 of 150. In other words, 150 divided by 2, and that is 75 degrees. Okay, so in one of the parts, we were given the angle, the 60 degrees, and we had to find the arc, and we found that to be 120 by doubling it. And then in the second one, we had enough information to know the measure of the entire arc in yellow by adding 120 and 30, and so half of that gives you the angle, which is right here, B. All right, so the second, the try it here says, in the first problem, what is the measure of angle A? And then in part B, there is an entire quadrilateral inside of this circle, and we're going to find the measure of all 4 of the angles. And each of these is actually going to lead us to another little set of theorems here about inscribed angles that are very important. So the first one is, what's the measure of angle A? And let's just put a question mark right there, the one we want to find. And again, if I would take my highlighter for a second, this is an angle that is inscribed in the circle that ends up intersecting this arc right here. Okay. Now notice there are no degree measurements in this picture at all, but there is something curious here, and that is this other segment happens to go straight through the middle. Remember, that makes this a diameter. And if that's a diameter, that means that the yellow arc is a semicircle. So you might want to think to yourself now, how many degrees is it if I have a semicircle or half a circle? I think we already know that. Since the entire circle is 360 degrees and this yellow portion makes 1/2 of it, this would have to be, oops, wrong kind of pen there. This would have to be 180 degrees. This arc is 180 degrees. And now we backtrack to the angle and say, well, the relationship is if I know the arc, I take half of it to find the angle. So that makes this 90 degrees because it's half of 180. Okay. Now, part B is a little more involved. We have to find all 4 angles. So there's angle A, B, C, and D. And so let's just start with A. Now, A is this angle right here. I'm going to take the blue pen again. And let's highlight it. Angle A is this one. Now, it's an inscribed angle. And the arc that corresponds to it is the one that goes all the way around here. So for that one, we have to add both of these arcs, which is 100 and plus 90. Okay, so for the measure of angle A, it would be needed that we find the combined measure of this arc in yellow, which is of course 190 degrees. So we have to find the combined total of that arc, 190, and then we take half of that. So we're going to take and divide by 2. So 190 divided by 2 is going to be 95 degrees. So let's put the 95 degrees right here, and then I'll erase these highlighting again. Okay, so let's erase this, and we'll put the 95. Now, while we're at it, we'll be working around this shape in the same way for all of them. So if I want to go to angle B, it is the inscribed angle up top here, and if I trace along its sides, the intersected arc is ADC. So what I'm going to do is add up 64 and 90 this time. That makes 154. And so now that's going to make the measure of angle B. So we got 154 divided by 2, and that should be 77 degrees this time. Okay, so we can start to put that up top there. If I work around to part C now, again, I'll erase the highlights along the sides here. So this one was 95, this one was 77. Now if I want to find angle C, I follow its angles over to the circle, and the intersected arc goes BAD, so I'm going to have to add 106 plus 64, and that's a total of 170. I'm going to add those together to make the entire arc around angle C, and that makes 170. And then I've got to take half of that because that's the inscribed angle. And so 170 divided by 2, let's see, that would be 85. Now, I know a couple ways to get the last one. One way would be to remember that we found for any quadrilateral, the total number of degrees is 360. And since we now know 3 of them, we could just take 360 minus 95 minus 77 and minus 85 and arrive at the last one. Or if we want to keep going with the same method as the other 3, angle D opens this way. Angle D opens up to the arc that goes A, B, C, and the total of those 2 arcs is 206. Okay, so for the measure of angle D, we could just take 106 plus 100, divide by 2. That's half of 206, and that's going to be 103. Okay, so what I'd like you to check before we move on is that now you should be able to check again, though, that the 4 angles that we found do add up to 360, because any quadrilateral, regardless of whether there's a circle here, the total should be 360 degrees. Okay? Anyway, so the 4 angles were 95, 77, 85, and 103. Now, those last 2 examples led to these 2 of these 3 little, what we call corollaries, which are theorems, but they come directly as a result of learning a previous theorem. So two of those last examples remind me of this one right here, which we call corollary 2, and it says any angle inscribed in a semicircle is a right angle. So in the last slide, you had a semicircle, 180 degrees, and if I inscribe an angle back onto the circle there, that's now going to be half of 180, so that's going to be 90, or a right angle. Now the other one demonstrated this. We had a quadrilateral in a circle, and we noticed one thing we knew before we even started was that the 4 angles in it make 360. But what we can see from the result of the previous example was that the opposite angles, in this one it would be A and C, and in this one it would be B and D, they end up actually being supplementary angles. Check it out. Let's just go back and look at the last problem again and see how that was, right? Look at angle A and angle C. If you take A and C and add them together, don't you get 180? 95 plus 85? And we do. And look at it again with angles B and D. They are across from each other, and if you add their angles together, you also get 180 degrees. And it's actually not an accident. So in any inscribed quadrilateral, if I look at the opposite angles, then angle A and the measure of angle C, they're opposite from each other, and they are going to be supplementary. They add up to 180. Similarly with D and B. They also make 180 degrees. And so let's use these now one more time. So this is problem 2, part A, and we're looking for the measure of angle 1. And if you saw the last corollary, this is a quick answer because angle 1 opens right here. Here are the 2 sides. And across the top of this is a diameter, which means the arc across the top is a semicircle or 180 degrees. And so that corollary says, okay, if this is a semicircle, the intersected or the inscribed angle to that has to be 90 degrees. And so that's just it right away. If it's inscribed into a semicircle, it's exactly half of this. If it's exactly half of that, now it's down to 90 degrees. And finally, here's another quadrilateral, and this time we're going to try and make use of that little shortcut we just learned about the opposite angles. So in other words, if I could figure out angle 1, I'll right away know angle 3. And if I can figure out angle 4, I'll right away know angle 2. Okay, so here's how I could, the givens were the arc across here, 60 degrees, and the arc across here, 80 degrees. Okay, so what I'd like you to think about is, which of the 4 angles will we be able to find first? It doesn't have to be angle 1. The way I see it here, if I take the 60 and the 80 and add them together and make 140, the inscribed angle that connects to that arc is this one that's actually measured angle 4. All right, and so I'm going to actually mention it first because it'll be half of 140. In other words, 70 degrees. So this one here is 70. Now, I just found 2 other ones that we can do very quickly, and that actually refer to the previous rule because there is a dotted diameter right here that connects angle 4 to angle 2. And if there's a diameter right there, I can just erase this now. This diameter across the circle is connecting this angle, the 2 sides of this angle right here. So we know that angle 1 is half of a semicircle. So the measure of angle 1 must be 1/2 of 180. So 90. And in the same way, angle 3 is doing the same thing as angle 1. It's intersecting that other semicircle. And so angle 3 would also have to be 90. Now it's 90 for another reason too, because remember in the quadrilateral, the angles opposite each other have to add up to 180. So if we already knew that angle 1 was 90, this one's going to have to be 90. So 90 and 90 make 180. And that leads to angle 2. And the shortcut here now is that it is directly across from angle 4, right? And we learned that in this inscribed quadrilateral, the opposite angles will be supplementary. So if angle 4 was 70, angle 2 would have to be 180 minus 70. In other words, 110 degrees. And now I've got all 4. I hope this helps you guys. I encourage you to backtrack and watch some of these examples again if you need to. And there's one last assignment today in Math Excel for problem set 12.3. The rest of the week you have a little review to do on Wednesday, and then you have a quiz. Your last quiz of the year will be on Friday, and that'll be it, unless you have makeup work to do. Hope this helps, and we'll talk to you soon.